Hi girls, now let us start the fourth unit, which is an important topic in this fourth unit, the minimum cost spanning tree. Let us discuss minimum cost spanning tree. Okay, so now let us see first what is the graph. Before we are going to learn the minimum cost spanning tree, we might have to know what is the graph. Graph is nothing but which are having the number of vertices and number of edges connected with a one is called as a graph. Okay, so in this minimum cost spanning tree is that first while we find out the cost of the minimum cost spanning tree. Here it is a weighted, connected, undirected graph. What is that? Minimum cost spanning tree is nothing but it is a weighted, connected, undirected graph. It is a graph. Why? Because why it is called as a graph? It having number of vertices and number of edges. Okay. So, but what is the speciality of minimum cost spanning tree? It is a weighted, connected, undirected graph. The cost of spanning tree is a sum of single cost. Cost of the spanning tree is number of sum of single cost. Okay, we find the spanning tree that has a minimum cost. Look at this diagram. It consists of 8 vertices. 1 2 3 4 5 6 7 8 8 vertices is there, and number of edges is, look at here, 1 2 3 4 5 6 7 8 9 10. Number of edges is in graph having 10 edges, but according to our formula the spanning tree has only n minus 1 edges. So here the n is number of vertices. Number of vertices are 8 minus 1, that is called as 7 edges. So actually here we having the 7 having 10 edges. Okay, 10 edges, but here we having only 7. So eliminate 3 edges. Need either select edges or directed eliminate 3 edges. The selection process of this greedy method having two methods. The first method is the Kruskal algorithm apply, and then second method Prim's algorithm. In Kruskal algorithm having the T3 conditions, start with the n vertices and 0 edges. Start with the n vertices and the 0 edges. Consider edges in the ascending order of the cost. Select the edge if it does not form a cycle. The main aim of this in the minimum cost spanning tree is select the edge if it does not form a cycle. And the second method, Prim's algorithm, applying Prim's algorithm. In the second method, start with the one vertex and grow it into the n vertex tree by repeatedly adding an vertex and a edge. Okay, condition is that when there is a choice, add least cost edge. Okay, when there is a choice, add least cost edge. And so these two are used in the selection process. How suppose we want to reject or eliminate the edges, just we have to apply these two rules. Okay, the first one is start with the connected graph repeatedly, find a cycle and eliminate the highest cost edge in the cycle. Stop when the no cycle remains. And second rule is that consider the edges in a descending order of the cost and then eliminate an edge provided this leaves behind a connected graph. Okay, these two rules. One is the first rule is to eliminate the edges which are having the highest cost, and second one is eliminate the edges which is having in descending order, which is having the behind leaves behind in a connected graph. Now let us see the example in the Prim's algorithm. Look at this picture. Look at this one, Prim's algorithm. So this one is the graph. Okay, in this graph just we apply the Prim's algorithm. So here how many vertices is there? 1 2 3 4 5 6 7 vertices is there. Okay, n minus 1, 7 minus 1, 6 edges is there. Now we find the minimum cost spanning tree applying the Prim's algorithm. First we have to select the A. Okay, vertex A. First we have to select vertex A. The A connected with the D, B and F. A connected with the three edges, A to D, A to B, A to F. In this, which one is the minimum cost? A to B is the minimum cost. So first we have to draw the minimum cost A to B. Okay, A to B. Next B connected with the A to D, B to D, B to E, B to C, B to G and B to F. Here which one is the minimum cost? One is the minimum cost. So just we have to draw the minimum cost B to D. B to D. Okay, and then the B connected with the, so B draw here B to D and D connected with the E and A. Suppose if we apply it D to A, it form a cycle. So according to our Prim's method, so we eliminate the cycle in the tree. Okay, then we have to select D to E. D2 is having the minimum cost, that is 2. And then let us observe here. Come back to here. B and B connected with the G and F. Suppose if we draw the F, it form a cycle. So I have to select the minimum cost is G. So that B to G and then G to F and G to C. So like this we have to select the minimum cost edges and visit all the nodes, and finally we find out the weight of the graph, that is 2 plus 1, 1 plus 2 plus 4 plus 6 plus 1, that is the weight graph is 16. That graph is 16. This one is the minimum cost tree of the Prim's algorithm. Thank you. Let us discuss in later classes Kruskal algorithm.